Hello guys and welcome to a new video. This time the final case from the Microsoft Excel World Championship chapter DACH. The last case missing from Leipzig, and yeah, it was a case I failed on, again, as often before. So I will talk to you about how to avoid it. But without further ado, let's jump right into it. So the height of mountains can be calculated based on different reference points. So height of a mountain does not mean the same everywhere. And yeah, we are dealing with this today. But first I need to make this a German number. Therefore I substitute the meter against nothing and the point against a comma. And then it's called Normalhöhen 0 or NN. I am converting this by, is it adding or subtracting? That's the question. I think it's subtracting. An example here would have been nice, but yeah, we might do it also that way. Sounds okayish or looks okayish. XLOOKUP JSON in this list, returning this number here, this normalized number, and then XLOOKUP because we now convert it into another reference point. 28. No, sorry. One step back. This is in centimeter, so it needs to be divided by 100. Not the mountain, the XLOOKUP thing. And this also 100. Okay, and then it's simple this plus this. Okay. Set. Okay, I do not know what is wrong with those numbers. They're slightly different. I think here it's 1 centimeter, and here it's 2 centimeters. But I'm not sure why, because the calculation method would otherwise say something else. So I'm not sure what is wrong with those. Anyways, you want to climb a mountain, which is the given height in meters. Which mountain is closest? Min lookup ABS of this minus this number, returning this number, Kreuzjoch. Everything right, and here this is given in normal height, and since we have calculated everything or converted everything before, we can now use it. Yay! I'm planning a tour. Okay, data table. Snipping tool is open. Planning a tour. You want to climb 3 mountains, aiming to get the possible thing. We have 83 mountains, so we use percom up to 83, use 3 numbers. Order of numbers matter, no. Allows the same number combinations, no. Okay, 91,000 combinations. First get the height. Get the height in normalized height, and then get the sum by row, and the minimum difference min match, yes, min match of ABS of this here minus this here gives us the row, and the goal row is then given by the row the combination is appearing, whole column. Okay, now we have the combinations. Yeah, to call index of height and the index number given, and the same we then do for the names. Okay, and now we sort it, sort by -1, Finster, it's the same, concat, right, left, sorry, I'm switching left and right sometimes, which is not great for Excel esports. Before. Okay, everything right so far, and since this case I haven't told you before, but this case is 2 cases in one, and therefore I will first do the bonus questions related to the first case before going to case number 2. And also I've talked to you before about what went wrong, or that something went wrong, and what I not considered was like going deep into what does this conversion mean. So I think instead of minus I used plus, and then nothing was matching. So sometimes, even if you're under stress, even if you're live, if you're streamed, go one step back, breathe once, and then do it again. And this would have helped me with this case, because I think in the first case I scored next to nothing thanks to this. So yeah, let's do it. How many mountains end with Spitze or Spitze? It's therefore Spitze has 6 letters, so it's sum minus right 6 equals Spitze 25, which is right. What is the total height of all mountains whose elevation is given in meter over area, and provide in meter over mehr? Okay, to convert it we need to add, and therefore this plus this divided by 100, and now everything with the area is here, and it's that number. Yes. What is the total elevation difference across all mountains between the reference point and the height above normal? Round your answers to 2 decimals. So it's sum ABS of this and this. 21.56, which is wrong 2 centimeters, but this might be, I have no idea why this is slightly wrong, because the method is should be kind of clear, but yeah, I will not run out for that point. Now The second case, go to the second case. The second case is a map case, so to say. And yeah, the first level is in basic indirect with a sheet given. I could choose easy indirect, lambda, or simple this concatenation method solved. Now local peaks. This is not difficult, but you first have to understand what is done here. So a local peak is, so to say, a point where no other non-diagonal cell is larger in the given, and you always go in the given order. So you're starting here from this cell, and now you go into south, north, east, and west. So let's cell, this is the cell, CR for reference is A stack. We are including the cell, we are saying cell ref based on a reference and movement. Okay, I should use UC. Also C. So first, south is column 0, row -1. Then north is column 0, row 1. East is column 1, row 0. And west is column -1, row 0. So, and now I have the cell references. I can show this. And I want to have the height of the cell reference. Therefore, I'm using easy indirect. The cells are CR. The sheet name is mountain map. Name this H for height. Yes. And we're then using max lookup for the height, returning the cell references. And here we're seeing, okay, we're going to AN13 because there's the local height, then to AN15, and at a certain point we're not going further, and this is then our local height. And we have it. 81, 100, B1, B4. Oh, here's an error. Ah, yeah, of course, because we're starting here with some border issues. I could have used here borders, but let's simply use if error for everything and then C. If error C. If error and C. If error and C. And then we have BF3 as the value. Okay, we have some errors. 84. Interesting. Oh yeah, I haven't tracked it enough, it seems. Yes, that's the issue with having something like this. 81, 100, B1, B4. Okay, now it's solved. Yep, and that can happen, but it's not the worst of the world. Okay. Climbing to local peaks. Sounds like a data table stuff. And. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, B1, B4. Okay, You start at a given cell and want to climb to a local peak. First determine the local peak with this formula. Drag it properly. We have enough calculation power. Distance between two cells and the difference between those heights, because this is a height map, should not be larger than the maximum distance, so to say. So easy indirect mountain map is then the height, and the height difference, this is 0 here because this is the starting cell, but this minus this should not be larger than the maximum elevation. And here it is larger before we are reaching the local peak. So we are failing in doing that. Okay. Exceeds the maximum followed by an F. Okay, otherwise use the so this is larger max, and here if we're still like climbing, where's this false? No, here this is 1, and this is simple, this unequal to this. True, false. So here we would have reached the local height. So x match false. 6, so minus 1. 1, 2, 3, 4, 5. Okay, here the meters are 0. Here it's this plus 100. Plus the previous meters. And here we are failing. Reach, fail, x match false in here, minus 1, and min. Min of both is the height we're, or the length we're using, in this case 216, and since it is, this is unequal to this, it's a fail. Okay, we will have issues here. I can show this because this is unequal, and therefore we say if error, then take it until we reach it. Okay, but if this is, oh, then it's a text. Okay, that's an issue. If is empty, then this, otherwise this, and F. Okay. Mimic 101, 120, B1, B4. Okay, should be hopefully Hopefully fine. 0, we fail at the first one. Interesting. But everything right. Okay. Last normal level. Note this is a bonus question. Okay, why? No, it's not a bonus. Okay. Highest point on the map. Oh no, address lookup is faster. Address lookup max. No, I don't want help. Or max of mountain range. Lookup value in mountain range. And this will then return the address. Okay, tallest cliff. No. Okay, level 7. This was at least bonus 4. It's a little bit confused, a little bit mixed, mingled here. Okay. Data table is. How are we in time? 21. Okay. One final ascent stands between you and the title Excel Master. Now you want to climb to the highest point of the mountain range. To do this, you first need to determine its location. Okay. I cannot see the highest point of a mountain range. Is this the highest point of a mountain range? No. Don't. Move diagonally to the highest point. Okay. So it's quite similar to this one, except you move diagonally. You only move diagonally. So 1 minus 1 minus 1. From the starting cell. Once you reached the highest, correct row or column. Okay, I have no idea what you're doing here, Benny. I have no idea what I should do here. I want to climb to the highest point of the mountain range. First need to determine its location. Okay. From the starting cell, always move diagonally towards the highest point. Then here, the highest point is AJ33, which require ascent. Oh yeah, okay. If the optimal path. Okay. It's similar. Okay. I copied this. I should have copied before, but let's use this. Zero? No. Okay, here we are failing. That should be okay. Is this right? It sounds looks too easy. It's like basically a copy of level 6 with different. Okay, let's test. If that's right, then I should have done level 6 because level 7 is okay. We have a few errors. So 124. Why is this not possible? Oh no, should be possible. If error, return to this. You should be able to go some directions. CR. Yes. B100, B2. Oh. No. Do not know why this is failing. H is also returning values. And max lookup should return here something. Max lookup H and CR. X lookup max of H in H returning CR. NA. Interesting. Floating point might be floating point issue. No. I have all those references. I have the heights. I have the no heights. Next lookup in here B99. Interesting. No. Oh, okay. Okay, the 0 wasn't matching. That was the issue. And then we have here 126. But it might be that we're directly at the maximum. Okay. 121, 140, B1, B4 should be hopefully then right. No. Great. So I have not understood it. How it is done. This might be the subtraction, the downhill rule stuff. Okay, we're not able to reach this. That's true. Where are the rules? Here are the rules. So, to the highest point of the mountain range. To determine its location from the starting cell, always move diagonally to the highest point. Once you reach either the correct row or column. Oh. I have not read that rule with rows and columns. That's interesting. Okay. That's something I haven't considered. So it's not that easy, but also not super complicated. Okay. So the maximum location, so lock, is this RC okay. Doesn't matter. RC row number, column number, okay, difference RC, RD, row difference, and column difference. Okay, once you reached the correct row or column, you only move in that direction. And it doesn't matter. The first 0 is of importance. So first 0. So X match 0. And then the minimum of both. (17). So we first move the first 17 steps in that given direction. 17, yes. Take 17 until AN38, which is in this case the local or the maximum thing. Here we are reaching it further and then move with the diagonal steps, whatever. And after that we are moving in the remaining direction. Okay, I should have split this into row and column. It's also not working because this should be column. Doesn't matter, but for this case, row, column. And then we're only going column difference in the direction where we have a difference. Okay, so is this row or column? Let's do it on example on 121. Here it's a row. We therefore only move columns. Okay, if column movement, row movement, if this is smaller than this, then the column movement is missing, but we do not know in which direction. Oh no, we don't need this. We can simply say why is this then index, or take here the last one, take the column number minus the location of the minimum, column number of course, or not minimum, whatever this point is. It's the highest point of the mountain range, so to say. Not so to say, it is the highest point of the mountain. Q to N is minus, so it's not N, O to Q. Oh no, this should be the other way around. Two, column movement plus 2. And now row movement is 0. Okay, not let, VStack this plus cell ref based on reference and movement, and take -1. Column movement is sequence, and sequence this might be an error. If error, then 0. If error, because sequence cannot be empty. Yes, good. And now we need this elevation thing stuff we've used here, but let's do it separately. So this is the movement, and this is height, equals easy indirect mountain map difference. Yeah, okay. And we also stack in here the starting cell once again. 0. Now make this dynamic. Drop 1 minus drop -1. No. Yeah. No, this is wrong. That's right. No, it's alright. 0 meters, 51 meters, 64 meters, 37 meters. Yeah, we're not climbing from there. Okay, so it's alright. And this should be larger, smaller or equal and the maximum. In this case, it's not an larger max diff smaller max, but let's change this. No. Okay, here it's also that way. Whatever this is. No. So equals, this should be unequal to drop drop -1 VStack 1. So we are always moving because we haven't reached the height. I think we could erase this because we're never reaching. We only need to check if we have the max, if we are climbing more than the maximum elevation. Is this different to the maximum elevation? That's confusing. So okay, let's interpret it as before. So we're failing. We have to scan 0 this plus 100 and some. Um, 174. Okay, yeah, then false. Okay, x match false in here, -1 index. Yes. If error. So if error, then rows if is error. Wow, this is taking 4 hours. If is error, then simply use this. If is error, use this. Otherwise, use this. This and F. Otherwise, use this. Okay. But it's an not is error. Why I should have used it the other way as I thought before. This is way more than I thought. This is this. Yeah, 45. This level 7 is hard to comprehend, or harder than I thought. Okay, we have a lot of issues. 122. Yes, because I haven't used this here. Hopefully. Otherwise, debugging. But only one bonus level is left, so. No! A lot is wrong again. What should be the answer here? 405 and not failing. Okay. So it might be that I'm interpreting the elevation rule wrong. You go from 1,000 to 9,000, then to 20,000, and so is it? But then the example 7 is not matching, right? Because if the elevation is simply drop 1 minus the starting point elevation, let's try this out. This is the starting point elevation. And if I interpret this right, I would fail way earlier. So it is not the starting point elevation, but it's also 100 meters before. Yes, this might be the issue. I should have checked if this would have matched the example given, because it has not matched the example, so yeah. But I think it's still wrong. Yes. And I have no idea what is wrong here. 121. So we're moving. This is larger than the example. The answer is 405, which is not the way I would have moved. So no idea what is wrong here, because my movement is not matching the movement intended. So it's 405 from A and level 6, 515F. Also not the same. 100 meters and 50 meters, 51 meters up. Okay, I'm matching the example, but I'm not matching much else. So I have no idea why it's not matching. It should be 515F, but it's fading before for me. So yeah, I have no idea. I will skip that level. If you have any clues what is wrong with it, write it down in the comments. Yeah. Okay, what is the height of the tallest cliff? One cell and its neighboring cell, only horizontal and vertical cells. Okay. Flatten map. Row and column. East or north, east, west, south and west. movement borders, cell reference, column movement is north, so 0, 1. Row border is 1 and 1. A2, no. North. North is -1. East is 1. B1. South is 1. And west is -1 column, 0 row. Yes. X lookup in here, returning the value here, and the elevation difference between one cell and its neighboring cells. List of one map. So it's this minus this, and then it's max lookup. Or is it? Oh, yeah, okay. Then it's simple the maximum of this. Which is not calculating an A. Do we have here an A errors in? Ah, yes, might be. If error, then 0. Calculate 388. Okay, at least that is wrong. Alright. So no idea about those level 1 and this small difference here. And honestly, no idea what is wrong with level 7. If you watch this video and if you know what is going wrong with my approach, it looks more complicated than this here. Please write a comment down below. Thank you for your attention. Hope to see you in the next one. Bye.